Today's video should be pretty simple, pretty easy to deal with. It's really just talking about the properties of parallelograms. We're about to go into a unit on quadrilaterals, and we're going to take each different type one at a time and talk about their properties. And then in class, what we'll do is we'll use algebra and other things like that and proofs that involve using those properties. So one thing you're going to need on this, you're actually going to need some color, because we're going to kind of color code this parallelogram as we talk about its properties. So if you need to pause the video and go grab your little brother or sister's markers, highlighters, whatever, do that. But you're going to need some color, and probably 3 or 4 colors would be good. Okay. All right. So parallelograms. First thing we're going to start with is the definition. A definition of a parallelogram is a quadrilateral with 2 pairs and so if I go over here, the first thing I want us to do, let's go ahead and name this parallelogram, and we want it to be parallelogram ABCD. So we're going to put some letters over here. This would be A and B, C, and D. Now, when you name a parallelogram, when you name any quadrilateral, you always have to go in order. So if I'm starting here, I'm going clockwise. You could have gone counterclockwise, it doesn't really matter. But if I'm calling it A, B, C, D, like it says right here in the box, then B is going to have to be between A and C. Okay, I can't go A, B, and then over here in this corner C, D. That wouldn't work. Okay. All right. So the first thing about a parallelogram comes straight from the definition, and that is that it has 2 pairs of parallel sides. So we're going to take and we're going to mark to show that these sides are parallel. So if you remember, parallel is the little arrows, so we're going to mark them with arrows. Okay, and over here we've got some arrows. Remember, this is clearly not parallel to the other pair we just marked, so we're going to use 2 arrows here. Okay. All right, and then let's fill in the blanks with some of these, and I'm going to change colors. Opposite sides in a parallelogram are always going to be congruent. Now this is a property, it's not in the definition, so if you were to see this in a proof, we can't say definition of parallelogram, we would have to say because opposite sides are congruent. So I'm going to come over here and I'm going to mark them congruent. Notice I'm using a different color so it doesn't get confusing there. Okay, so those 2 are congruent. BC will also be congruent. Let's mark it down here to AD. Okay. In the box, we're going to actually write our example from ABCD. So we've got, in this case, we have AB. There we go. All right, the next one, opposite angles. So I'm going to get a different color here. Opposite angles are going to be congruent. And also, so let's go ahead and fill in our blanks here. Our congruent symbol. Okay, so that means B, remember, if you remember from when we did trig, opposite means across from. So B would then be congruent to D over here. And you can kind of tell that they go together because those 2 are cute. And then A and C are both obtuse. Those match up. So A is congruent to C. Okay, so I'm going to come in here in the box, and I hope yours looks a lot prettier than mine. We can say angle A is congruent to angle C. And angle B was congruent to angle D. Okay. All right, now here's where it gets a little crazy, and this one I can't actually mark in the picture. Okay, so you're just going to have to write it, and then we'll talk about it. And that's consecutive angles are going to have to be supplementary. And that comes from the fact that we know these are parallel lines, if I were to extend those. So then we have parallel lines and a transversal, and we know that these right here, angle B and angle C, would be considered consecutive interior. Okay, and so they're going to wind up being supplementary. And I'm just going to take a different color here, and I'm going to abbreviate it. You can write the whole word out, but as fat as this thing is writing, it probably won't fit for me. So they are supplementary. Well, what does supplementary mean? That means they add up to 180. So I could say then, what we're going to write in here in the box is that we could say that A plus B equals 180. You know, we can go on and on and on. We can write them all. Okay, B plus C would equal 180. C plus D would equal 180. I'm only going to write one example for like a space here. Angle A plus angle B equals 180. So parallelograms are nice because they're very symmetrical. Okay. All right. And the last thing we're going to put on here is about our diagonals. And a diagonal goes from one corner to the other. Okay. So I'm going to go from D to B. Okay. And we'll go from A to C. Okay. And your diagonals, the thing that's interesting about the diagonals, and you can probably kind of tell why, looking with all those markings and everything that's the same. I mean, it has to do with the fact that we've got congruent triangles in there. But our diagonals are going to bisect each other. Okay. Well, let's go ahead and write that down first. I'm going to change colors here. Let me go to some pink. So diagonals diagonals bisect each other. So if they're bisecting each other, then that means they're cutting each other in half. Okay, and so I know our picture gets a little bit crazy up here, but we're going to go ahead and mark that in our picture. That would mean that I could come over here and I could say, let's put a little point in here. Let's call this point where they're intersecting. That would mean that from A to E is going to be equal to, and I really should put several marks here, but I'm just going to do it with color instead of different numbers. From A to E will be equal to E to C. Okay, and if I change here, let's see if we can find one we haven't used yet. How about pukey olive green? We could say that from B to E would equal from D to E. Okay. On yours, if you've got room, I would mark that with 3 and then 4 markings just so you can tell what goes with what. Okay, so go ahead and go in the box and let's record it. Okay, AE equals EC. AE equals, and I'm just going to write the one example. We can go ahead and record them both. I don't want you to sit here and stare at the screen while I struggle with this pen. I will get this down, I promise. Okay. But AE is equal to EC. Of course, the other one that you should be writing down is that DE equals EB. Okay. All right. So then here's what I want you to do. Okay. We've got all these properties, and of course in class the way you'll see it is there'll be algebraic expressions. AB is x plus 5 and CD is 3x minus 2, and you have to know, oh hey, they're equal, and set them equal and solve. And that's kind of the way you're going to see it used most of the time. But another thing you're going to see is you're going to see it in proofs. In fact, you're going to see it in your proof packet. So to get us kind of started in that direction, I want you to take a look at the bottom, what you've got on the bottom of your page. If we know that that's a parallelogram and all those things up above go with parallelograms, I want you to see how many different reasons you think you could use to prove ABD is congruent to CDB. Okay, well, one thing I know for sure, take a look at this picture. Let's go ahead and mark everything that our properties tell us. Okay, we know for sure that my opposite sides are congruent. So this is equal to that, and this is equal to that. We know by reflexive property, AD is going to be equal to itself. So I could stop there and that's enough, right? What would the reason be? It would be side, side, side. But we also know, another thing we saw in there is that opposite angles are congruent. So if I throw that in there, now I've got another option. Now I could say side, angle, side. Okay. And so there's lots of different ways that I could use that. I'm going to challenge you to see if you can figure out if there's a way to use any of the other reasons here for this exact proof. There might be, there might not, but I want you to take a look at it. Okay, and we'll talk about it in class, and we'll do further practice in class. So see you in the morning. Okay. Lord have mercy. That was rough. I almost rather prefer the mouse.